What if your phone, your laptop, even your headphones just stopped working? What if the invisible ingredients powering modern life, rare earth elements, suddenly vanished? Today, we're imagining a world without rare earths. And trust me, it's a future you don't want to see. Rare earths aren't actually rare, but they're tricky to extract. 17 strange sounding metals like neodymium, europium, and yttrium are the hidden architects of modern technology. Their magnetic, phosphorescent, and catalytic powers make them irreplaceable. Without them, the world we know doesn't just change, it collapses. First to go, your electronics, phones, TVs, smart devices, dead. At first it feels like a power cut, but then it spreads. No GPS to guide planes and ships, no satellites feeding your maps, weather forecasts, or internet. Even defense systems crumble. Stealth aircraft, guided missiles, advanced radar, all useless without rare earths. It's not just inconvenience anymore, it's a global blackout of both comfort and security. But the impact doesn't stop at your pocket. Industries collapse as high-precision tools and catalysts disappear. The green energy revolution? Dead on arrival. No efficient wind turbines, no powerful EV motors, no advanced solar coatings. And in hospitals, MRI scans, X-rays, life-saving imaging, all gone. Centuries of medical progress vanish in seconds. We'd be thrown backward. Transportation reverts to fossil fuels. Farming loses GPS precision, slashing efficiency and food supply. Millions of jobs vanish as global supply chains collapse. Nations fight over dwindling alternatives, sparking resource wars. Humanity would adapt, but with bulkier, less efficient technology. Life would look less like the future and more like the past. Scientists would scramble to find alternatives. Some would experiment with ceramic magnets to replace neodymium, but they're weaker and make devices heavier. Others might turn to organic phosphors or quantum dots to mimic europium and terbium in screens. But the colors are duller, less efficient. Motors could try aluminum or ferrite substitutes, but they burn more energy and break down faster. In medicine, older X-rays and ultrasound would replace MRI and CT scans, but at the cost of clarity and accuracy? We'd still have technology, yes, but slower, bulkier, dirtier. Phones twice the size. Headphones the weight of bricks. Cars coughing smoke instead of running clean. Progress wouldn't stop, but it would stumble backward, costing us decades of innovation and leaving us stuck with weaker, less reliable replacements. Here's the twist. The good news? Rare earth elements aren't actually scarce. In fact, they're abundant across the planet. The challenge isn't finding them, it's extracting them safely. And that's where things get dangerous. Improper mining and treatment of rare earths can unleash environmental disasters. Radioactive waste can seep into groundwater. Acidic leaks can poison rivers, killing crops by disrupting chlorophyll production. These toxins can even reach our plates, entering our bodies, damaging lungs and livers. Without strict standards, every mine risks becoming another industrial nightmare. A disaster on the scale of the Bhopal gas tragedy. And here's the shocking reality. India holds one of the world's largest untapped reserves of rare earth minerals. They sit beneath our soil, waiting. But right now, we lack the safe and sustainable technologies to extract them. If we rush, the damage to our environment and our people could outweigh the benefits. The minerals could power the future, but without care, they could poison it too. So the real danger isn't us running out of rare earths. It's extracting them unwisely. If we don't get this right, the tragedy won't be losing our technology. It'll be losing our health, our food, and our planet. Rare earths may be the hidden architects of modern life, but how we handle them will decide the blueprint of our future.